All right, let's do problem 5. A culture of bacteria grows exponentially. If 140,000 bacteria are present initially, where can I put that in my equation? Oh, P naught, initial population size. All right, so I know 140,000 are present initially, and there are 609,000 present after 6 hours. So how much after 6 hours? 609,000, so that 609,000 goes right there. E to the K, I don't know my rate, but I do know the time is 6 hours. I've filled out my equation. How many will be present after 8 hours? So I need to figure out my rate, K. So notice I'm not using the 8 yet. I'm using 6 because I know that after 6 hours, so that's where my 6 goes, after 6 hours, the initial population of 140,000 has grown to 609,000. So I need to use that to find my rate. So I'm going to solve this in the same way that I started to solve that last problem. I need to isolate the exponential part. So 609,000 divided by 140,000 equals e to the k times 6. Notice that all those zeros are going to cancel, and I'll just have 609 divided by 140 because math is cool like that. So now I need to get that exponent down, and I do so using logs. What log? Well, I'll do the natural log because this is a base e problem because the exponential is base e. So the natural log of 609 divided by 140 has to equal 6k. And I don't want 6k, I want k, so I have to divide by 6. So the natural log of 609 divided by 140, close the parentheses, divided by 6, that should equal k. And k is roughly 0.245, but do not round at this point. You should never round in the middle of a problem. You want to store this variable. So remember, hit the store button, which is underneath the natural log button. Store this as a. So hit alpha math to get a up, and then hit enter. We've now stored that variable as a. And now we know the rate of growth, so we can figure out how much bacteria will be present after 8 hours. So we use our model. We're starting with 140,000. And then E times K, I'm now using A to represent K. It's that stored value. So A times my time is now 8 hours. So now I'm using the 8, and no logs involved in this problem. I just want to know what's the population after 8 hours. So this is just a plug and chug problem. If you look at your calculator, bring mine up real quick. If you look at your calculator, if I was typing this in, I'd type 140. And then, if you look at the LN button right here, it has a little E to the X symbol above it. That means if you hit second first and then natural log, it'll actually give you E with an exponent, like that. On a newer calculator, it gives you the box. So I would type 140,000 E to the power of blah, and then I would put A times 8. I would just straight up do A 8 like that, and that'll do it. If you're on an older calculator, you're going to want to do 140,000. Do the same thing, hit second ln to get e to the power of x, but on yours it'll give you an e caret with a parenthesis like that. And then on yours you'll want to type A8 in there, so hit alpha math to get A, and then type 8, and then close your parenthesis, and then you should be good, and you should be able to get your final answer, which is 994,138.848, rounding 8477 up to 848, and that should be our final answer. Now, if you don't store that rate and instead use 0.25, you'll get 993,905.789. So you'd be off by like 220 roughly bacteria, which is, I don't know, it seems significant. Maybe not when you're talking about a million, but still, it's off. So if you don't store you are creating error that you don't need to create, and you're not going to receive full credit for that answer. So please do store that variable.